students. Welcome to Nuclear Physics 1, lecture number 12. I'm Dr. Farwaz Ahmad. In this particular lecture, we will continue our discussions on the decay rates. Here is the formula, the mathematical relations for the decay rate, and that is given by R is equal to lambda n. So let's proceed towards our today's lecture, that is the decay rate. You remember that normally we do have calculations whenever we have a particular type of the radioactivity. In radioactivity calculations, we remember we are more interested in the decay rate than in the number of the radioactive nuclei itself. So the decay rates normally we denote it by R, and that is equal to dN over dt. That is the rate of disintegrations. The R is equal to the rate of disintegrations. What actually now we have a question that what actually we get from the decay rate. So we remember this decay rate, which we denoted by R. This gave us the number of the nuclei decaying for unit times. So now, this is somehow a formal definition for the decay rate. That is, if someone asks you what is mean by the decay rate, so this actually, so you have to answer that a decay rate is the one which gave us the number of nuclei decaying for unit time. In short, we can say that the decay rate is basically the nuclei decaying for unit time, or we can say the total number of nuclei decaying for unit time. So now the next question is how we can calculate the decay rate. Uh, so now, this is the second question, that how to calculate the decay rate. So for this, you should know that R. You should know something, and if you even don't know something, so how you can proceed? Uh, if you don't know the number of the nuclei in the sample, by simply measuring the number of emissions of alpha, beta, or gamma particles in 10 or 20 seconds, we can calculate the decay rate. What is the important thing for the decay rate? Do we need to know the number of the nuclei in the sample for calculating the decay rate? So the sample answer is no. So if we don't need to know the number of nuclei in the sample while we are calculating the decay rate, so how we have to proceed? So here is the method for proceeding for calculating the decay rates in case if we don't know the number of the nuclei. That is what we have to do. The sample track that we have to do is, if we have a sample, and from that samples, if we have the emissions of alpha, beta, or gamma particles, so we should note the interval. We should take a particular interval, that is the intervals that might be of 10 second or 20 second. So from that we can easily calculate the decay rates of that particular sample. So for that, to be very specific, let's say that we consider the time intervals dt, and get a decay constant delta n, that is equal to minus dn. So the decay rate is now defined mathematically as r is equal to minus dn over dt. That is how we do the mathematical tracks. Here we given the example of in sample numbers, but here if you want to derive any relations, a mathematical relation, so for that we have to do some considerations, and we consider the time intervals. It is a short time intervals dt, and we get a decay constant delta n, that we say equal to minus dn. then the decay rate is now defined as R is equal to minus dN over dt. Um, and also, if you recall your knowledge your knowledge of that of reactive decay law that you people have learned in the previous lectures, you know that uh, n is equal to n naught exponential minus lambda t. That is the law of radioactive decay. We have discussed that in the previous lecture. So if we differentiate it on both sides, I mean, we differentiate it on both sides with respect to t. We will get r is equal to lambda n r exponential minus lambda t. So how we get this? So here is the easiest track, that is we differentiate on this side with respect to t, that we will get dn over dt. So dn over dt, just like we mentioned on the other side, is equal to r, minus r. We say that r is equal to minus dn over dt. And on this side n is constant, so we when we apply differential on this, so we will get minus lambda n r exponential minus lambda t. So minus and minus will cancel and we will get these relations, that is r is equal to lambda n r exponential minus lambda t. I mean, it's the easiest mathematical track. You can do that by having a proper knowledge of the basic mathematics at the O-level mathematics or A-level mathematics. Or if you get a more simplified form, so you can write this equation as r is equal to r naught exponentials minus lambda t. So what is r here and what is r naught here? So we remember here r naught is the radioactive decay rate at time t is equal to 0. I mean, here we are talking about r naught. So r naught is the radioactive decay rate at a time t is equal to 0. And what about r? R is the rate at any subsequent time t. So both of these are the radioactive decay rate, but R is at the time t is equal to 0, and R naught is the time t is equal to 0, and R is the rate at any subsequent time t. And we remember these relations, that is R is equal to R naught exponential minus lambda t. This is the alternative form of the law of radioactive decay. Now, you also know from equation number 1, that is dn over dt is equal to, or we can say that dn over dt is equal to lambda n. I mean that you can recall from the previous lectures where we have denoted as equation number 1. So from your knowledge of this equation 1, we can rewrite the previous equations, that is the equation on the previous slide, that is these relations. I mean, we can write these relations, or we can write the relation on the first slide, that is this relation. We can rewrite these relations on the final slide as we can write it as r is equal to lambda n. So here R and the number of the reactive nuclei that have not yet undergone decay must be evaluated at the same instant. So this is a more simple relations for the decay rate. So the decay rate is equal to uh, the decay constant time, the number of nuclei that we have at any instance of time t. So that's all we have for this lecture for the decay constants. Thanks for watching. See you in next lecture. That will be lecture number 13. And that lectures we will have discussions on the half-life, and mean life. So stay tuned for the next lecture. See you soon there. Till then, bye bye.